Today's lesson is on the Pythagorean Theorem, which is a big, scary word. It seems very intimidating every time I tell my students we're going to learn the Pythagorean Theorem, but it's actually just a formula. And we're going to start by watching a little video clip from YouTube. Before we start the video, I want you guys to open your spirals to a new blank page. And at the top of the page, go ahead and put the title of today's notes, the Pythagorean Theorem. You're going to pause this video and you're going to go watch the little 12-minute clip on YouTube. It's called Math Antics, the Pythagorean Theorem. Hopefully after watching that video, you're less intimidated by the Pythagorean Theorem and see how simple it is and that it is simply used to find a missing side length of a right triangle. We will talk in a minute about where it came from and how it was discovered, but you saw a little bit of that in the video. So the main thing the Pythagorean theorem is used for is to find a missing side length of a right triangle. So if we have a right triangle, which is a triangle that has one right angle, and we know two sides, we can find the third side using this formula. It is important when you're talking about right triangles to understand that the different sides have different names, because when you're looking at the formula, you have to understand which letter in the formula represents each side. So two of the sides in a right triangle are called your legs, and the legs make up whatever two line segments come together to form your right angle. So in this triangle, these two sides meet at this vertex to form this right triangle, which makes both of these sides your legs. The side of the right triangle that is opposite of your right angle and is not used in forming the right angle is called your hypotenuse. In the formula that you saw in the video, the legs are your A and B. So this could be side A and this is side B. It does not matter which one's A and which one's B. So this leg could be A or it could be B. This leg could be B or it could be A. The hypotenuse in your formula must always be side C. Remember, the letters A, B, and C just represent an unknown side length. I could use any letters to represent these sides as long as we know that the sum of two of the sides squared will equal the sum of the third side squared. So this is an introduction to what the Pythagorean theorem is used for, as well as identifying the names of the different sides in a right triangle. Take a minute and pause the video and copy this into your notes. So this is the formula for the Pythagorean theorem, and as previously stated, these two letters represent your legs, and this equals your hypotenuse. And again, A, B, and C are the general letters that we will see in this formula, but we have to remember that it could be any letters as long as we understand that two of the legs have to add to equal the third leg. So I could make this E squared plus F squared equals G squared, where my legs are side E and F and my hypotenuse is side G. As long as we know that both of the legs are squared and added together to give you the side length of the hypotenuse squared. So take a minute and get this formula written in your notes. I would write it very large in my notes. I would probably put a box around it or highlight it and maybe put a big star next to it, because until you have this memorized, which hopefully you already do, it's not a difficult formula, this is what you will reference the most often as you are practicing it. So go ahead and pause the video now and copy this into your notes. So let's just talk briefly about where it came from and what was discovered. So the video told you that it was probably discovered by Pythagoras. There is a little bit of debate on who actually discovered it. But what's more important was what was recognized or what he understood and what he figured out. And I just want to make sure you really understand where we're getting this c squared. So what he realized was that when you had a right triangle, it didn't matter how big or how small. If you drew a square, a perfect square, using the side lengths of the triangles for each square, that the side lengths of the legs, if you took the area of the squares, which is a times a, or a squared, and b times b, or b squared, those represent the area of those squares. It would give you the area of the hypotenuse, c times c, or c squared. So the area of these two squares added together equals the area of this square. And I really liked, and this is probably the main reason I made you watch the Math Antics video, is because they're able to show you those two squares and move it and do the digital manipulation of the image to show you how those two squares combined equaled the area of this third square. So this shows you the formula, just reminding you that a squared and b squared represent the area of squares that could be made using that side length as one of the sides of the squares. So the area of square A plus the area of square B gives you the area of square C, which is why in order for us to find the side length, we have to not figure out what c squared is, but figure out what c is. And the reason for that is we don't want the area of the square, we want the side length of the square. So if we wanted just c from c squared, we would find the square root, which is the inverse of the square. So say the area of the square is 16. That would mean the side length would be the square root of 16. So c would equal 4. So remember, when we're using Pythagorean theorem, we're finding the area of a square. We are looking for the side lengths of one of the sides of the square. So we're not going to want b squared as our final answer. We're going to want to square root that. So you'll see the last step in solving for the Pythagorean theorem is finding the square root of whatever side is left. So let's take a minute and pause the video and get this copied into our notes. So now we're going to look at two examples. Here we have the right angle and we have the two sides 6 and 8. So those are our legs, and we're missing our hypotenuse. So when we plug it in, we're going to plug in the legs for 6 squared plus 8 squared. And we're missing the hypotenuse, so we have x squared instead of c squared. So we're going to go ahead and start by solving the legs that we know. So 6 squared is 36. 8 squared is 64. Add 36 and 64 to get 100. And again, we have x squared equals 100. This is what I was talking about on the previous slide. So I don't want the area of the square. I want the side length. So in order to figure out what x is, you have to find the square root of both sides, square root of x squared and the square root of 100, to just get what x equals instead of what x squared equals. So you're using your inverse for the square of x, which is the square root. So x equals 10. I like this one a little bit because this triangle is turned. So don't worry about what way your triangle is facing. Worry about where are your legs. So if this is my right angle, the two sides that make up the right angle are your legs. So this time I'm actually missing a leg. I have one leg, I have my hypotenuse, and I'm missing the other leg. So when I plug it in to my formula, it's going to have to be on the side where I'm adding the two legs that has the missing value. So that gives me a little bit of an extra step here. I have 12 squared, which is 144, plus y squared, one of my legs, equals 13 squared, which is 169. So I have to subtract 144 from both sides to get 25, and I have y squared equals 25. Find the square root of y squared and the square root of 25, and y equals 5. Something you guys should be paying close attention to, I know I didn't say this earlier, but your hypotenuse is always your longest side length, always. So if you're solving for a leg and your answer is longer than your hypotenuse, that should be a way for you to self-check and see that you've probably made a mistake. So if I'm on this problem, I know that my answer should be more than 6 and 8. If not, I've probably done something wrong. If I'm on this problem and I'm solving for a leg, I know that my answer should be less than the hypotenuse. It has to be less than 13. If not, I'm probably doing something wrong. So keep that in mind. Your hypotenuse is always your longest side length. If it's not, stop and check your work. You're probably making a mistake. Okay, let's pause the video and get both of these examples copied into your notes. All right, guys, so now it is your turn. Let's get our socks and markers out. And I want you guys to try number 1 on your desks. You are going to try number 1, and then when the majority of you guys have finished trying number 1, we're going to press play on the video and I will work it out for you. So go ahead and pause the video and try number 1 on your desk now. So number 1 is missing the hypotenuse. So we have 13 squared plus 17 squared equals c squared. And 13 squared is 169. And 17 squared is 289. So we're going to add those two together to get 458 equals c squared. And then you don't want c squared, you want c, so you're going to have to find the square root of c squared. And to keep it balanced, you have to do the same to both sides. So we're going to find the square root of 458. And I should have said this before we started, but let's go ahead and for the sake of all of the answers, if they are decimal places and they need to be rounded like this one does, we're going to round it to the tenths place. So c equals 21 and 4/10. And I'm sorry I didn't say that before we started. So for all future problems, feel free to round them to the tenths place. And you could even say this is approximately 21 and 4/10. All right, guys, let's pause the video and try number 2. So again, on number 2, you are also missing the hypotenuse. So we have 14 squared plus 3 squared equals c squared. 14 squared is 196. 3 squared is 9. So 196 plus 9 equals 205. And we're going to find the square root of both sides. And we have c equals 14 and 3/10 approximately. All right, guys, number 3 is a repeat of number 1. They are exactly the same problem. So we are going to skip number 3, which is kind of perfect because I don't really have enough room to work it out. So let's keep on going and let's try number 4 on our desk since we've already done number 3. So number 4, we're missing the hypotenuse. So we have 16 squared plus 8 squared equals c squared. 16 squared is 256. 8 squared is 64 equals c squared. 256 plus 64 equals 320. We're going to find the square root of both sides, and c equals approximately 17 and 9/10. If you rounded that to 17 and 8/10, I'd mark it wrong. I did say round to the nearest tenth, and we are not going to be getting credit because it's close. We need to know how to round in pre-algebra, so make sure you're rounding correctly. All right, pause the video and try number 5. So again, we're missing the hypotenuse. We have 11 squared plus 7 squared equals c squared. So we have 121 plus 49 equals c squared. So 121 plus 49 equals 170. We're going to find the square root of both sides. Square root of 170, C equals approximately 13 for our side lengths. If you wrote 13.0, that's fine, but you really don't need the 0.0. Pause the video and try number 6 on your desk. Number 6 is the first one where we are missing a leg, and I don't quite have enough room to do it down here, so I'm just going to draw an arrow and kind of work it out on this space next to it. So we have 12 squared plus b squared, we're missing that side length, equals 15 squared. So I have 12 squared, which is 144, plus b squared equals 15 squared, which is 225. So we have this extra step of subtracting 144 before, well, I guess it's not really an extra step. In the previous ones, we had to add the a squared and b squared, and here we have to subtract one of the legs to get the b squared. So it's not an extra step as much as it is a different step. So you have 225 minus 144 equals 81. So we have b squared equals 81. We're going to find the square root, and b equals 9. Perfect square root. All right, moving right along. Let's pause the video and try number 7 on your desk. So again, on number 7, we are missing a leg. So we have 6 squared plus b squared equals 9 squared. And 6 squared is 36 plus b squared equals 81. And we're going to minus 36 from both sides. So b squared equals 81 minus 36, which is 45. We're going to find the square root of both sides, and b equals the square root of 45, which is approximately 6 7/10. Pause the video and try number 8 on your desks. This is kind of hard to see. This is 1 yard, and this is 4 yards if you can't see that. So again, we are missing a side length. So we've got 1 squared plus b squared equals 4 squared. 1 squared is 1. 4 squared is 16, minus 1 from both sides. B squared equals 15. We're going to find the square root of both sides, and b equals 3.9, or 3 9/10. All right, we have one more. I do not have enough room. I'm going to have to erase to do number 9, but you've got room. You can erase on your desk, so go ahead and pause the video and try number 9. All right, guys, let's try number 9. I erased number 8 so that I would have room for number 9. Number 9 is also missing a side length, so we have 8 squared plus b squared equals 10 squared. 8 squared is 64 plus b squared equals 10 squared is 100. We're going to minus 64 from both sides. And we have b squared equals 100 minus 64, which is 36. And then we're going to find the square root of both of those, and b equals 6. You guys hopefully are doing really good with this. This is pretty fun. One of the easier things that we learned this year. My students tend to do very well with Pythagorean Theorem. And we are going to talk about the distance formula after you've had a little bit of time to practice and get really good with the Pythagorean Theorem. And I'm going to show you how we use the Pythagorean Theorem to find the distance between 2 points on a coordinate plane. So that's where we are, and that's where we're going.